Let me stop sharing just to make sure. All right. So welcome everyone to the Yash, if you could help admit people in as they come in because I can't see that. Very cool. So welcome everyone to the Python 1 workshop in collaboration between CPP Hyperloop and IEEE. You do not need to be a member of Cal Poly Hyperloop or IEEE to join. That is just where we advertise it to, so we can get some people in here learning new skills. Let's see here. Josh, did you invite the waiting room people?
Yeah.
Okay, awesome. Just making sure. Okay. So welcome everyone. Today we're going to be going over a lot of different topics. We're going to go over the introductions and goals, and then we're going to move on to setup. So you guys will be getting some hands-on practice in the pain of setting up some of this software. It's actually not that bad. Visual Studio Code is very quick and easy. I like how Microsoft made it so that it'd be easy to share and set up. You're going to be setting up Python. You're going to be setting up some VSC extensions, and then we're also going to get you set up with GitHub Desktop, GitHub, and making your first repository. All right. So after that, we'll go into the basics at 2:25 p.m. So we'll go over print statements, input, output statements, data types, basic arithmetic, conditionals, loops, functions, and how to troubleshoot problems that you may find inside an individual setting or in a group setting. So we're going to go over collaborative coding and how you can make your and your partner's lives easier when coding along with them. After that, we'll talk about problems and applications. So different things you can do with Python, different games you can make, different applications, and we're going to also talk about how we use it in Hyperloop. So one of the main things I stress when creating these workshops is that they need to have Hyperloop applications, which means that you come to this workshop either to be interested in Python or in general, or to find out how we're going to use this skill inside of our team. So our team being our Hyperloop team. And if you're here and you are a member of Hyperloop, that's great. If you want to review Python or know how it works, that's also great. So let's get started. So I realized I didn't introduce myself. So I'm Chris Lai. I'm the president of CPP Hyperloop, and I'm also the software lead here. And below me is Yash Karwal. You want to introduce yourself?
Hi, I'm Yash. I'm the Hyperloop's design team.
So Yash will be helping me run the CAD 1 workshop at 3 p.m. So after this hour, I'm just going to hand it off to him. He's going to take it from there. So you guys are free to stay in the Zoom call to learn about computer-aided design, SolidWorks, AutoCAD, Tinkercad, etc. It's a lot of fun. So we'll go on to the first slide. Let me go ahead and share these slides with you all first so you can access the links. I'm going to share link for this. So if you go in the chat, so this is the link to the PowerPoint that I'm going to be using. You can feel free to go on there and look at slide 3, which is the setup slide. We're going to go ahead and take a few minutes to just go to the different websites and set up all our tools that we'll need to like begin coding. So you'll take a note that, let me start sharing again. And if like juggle between all the different sharing types. So you'll notice that we have a sidebar on the left and a sidebar on the right. Feel free to ask questions at any time. You don't have to like raise your hand or anything, just like speak up so that I can help you and maybe Yash can help you as well. We're going to get started on Visual Studio Code. So you're going to click the first link on the left bar there, which has a label VSC compiler, editor, and linter. This will take you to a PC link. So this is for the PC version of Visual Studio Code. If you are using a Mac, you can also use Visual Studio Code. But it might be a different link. I'm not sure. So you just search up Visual Studio Code for Mac and you download the first link there. You can just Google it. Just as a show of hands, who has already Visual Studio Code installed on the computer and do not need the setup? Eduardo and Eddie, Gabriel. Awesome. Awesome. Good to hear. You can just, Jason. Very cool. Y'all can just chill for a moment while we get this set up. If you don't have GitHub Desktop set up, or if you don't know command line Git, you can always go ahead and start on the right bar there. You'll need to make a GitHub account. and then you'll also need to go ahead and download GitHub Desktop. And you can also download command line Git if you want. That's just an option for you. But all three of them will help you with version control and working in collaborative teams. If anyone is downloading Python from the open source, when you run the extension, when you run the .exe, make sure you click add to path. So you want to add Python to your computer's path. That way, let me open the website. So that way you will be able to, when you're working with like pip install or other dependencies, it won't give you errors saying it can't find it. So you would want to go ahead first download the Visual Studio Code compiler and then download Python either from the open source or Microsoft Store. You don't need to download from both, just pick one. Then you'll go ahead and here, let me share my screen real quick. So when you finish downloading Visual Studio Code, it shouldn't take you longer than a minute or two. You'll see this sort of screen. Uh-oh. Can everyone see the screen I'm sharing right now?
Yes.
Yes.
So I'm showing my Visual Studio Code. On the sidebar here, these are the extensions. So if you're at this point in time, you'll click on the extensions, you'll go search up Python, and you'll download this one, Intellisense, Pylance, linting, and debugging. So you need both the Python from the website or the Microsoft Store, and you need this extension in Visual Studio Code for it to work. It may prompt you to download some more stuff on the bottom right corner, such as Git. You can go ahead and do that. It's not that doesn't take that long of time, but I'm gauging how far people are into the download process right now. So if I'm going too fast, please let me know. I'm going to give you some time to get this downloaded. On the left bar there, I also have some useful extensions for you. So useful extensions are sort of like draw.io and MD Viewer. MD stands for Markdown Text. So when you're doing setting up a GitHub repository, you have an initial readme.md. That MD extension stands for Markdown. It makes text look pretty. That's pretty much it. And with MD Viewer, let me see if I can find it. So all you need to do is you type Markdown into the extensions, and you just click on the first one. It allows you to see Markdown directly translating to like its pre-form. If you work with like LaTeX or something else, this is pretty similar to that.
We just installed the Markdown.
Yes. So you can just install the Markdown, because if you want to write documentation in Visual Studio Code, that's what you'll have to use. Make it look pretty nice, because on GitHub it does show that as well. And then the other extension is draw.io. So if I do draw.io, I use this integration, the one by Henning Dietrich, basically puts like a flowchart maker inside of Visual Studio Code. So when I code, I like to make a lot of flowcharts just to make sure I understand it and everyone else who looks at my code understands it, because sometimes comments are not enough.
Sorry, which one is that? Is that the blue, the one that's the blue box with the white thing, or not one?
Yes.
Okay.
So this one. I think you use other ones as well, but I just like this one personally because it's worked for me before. So just a show of hands, if you are at this point in time, please raise your hand so I know if I can continue. If I see the majority of people raise their hand, I'll continue. Visual Studio 2019 is not the same thing, Aaron. You need Visual Studio Code. So Visual Studio is for like application-based design, which is not what we're after for. It takes like a heck of a long time to like build as well, because if you're using something like, or you're taking an EC course like 2310, you're going to use Visual Studio because they make you do like the GUI and stuff like that. But in here, we're just using Visual Studio Code. So it's the one with the blue icon, not the purple one. You're trying to get that. I believe Visual Studio is around like C#, C++. You build it in like folders. Yeah. I think you can get both and it's fine. I just like Visual Studio Code better because it's more practical. Okay, check how many hands are raised. All right, I'll give you a minute or two, and then we were.
What do I need to download from the Microsoft store? There's like 4 different versions of Python.
Okay, let's take a look at that. So Microsoft Store is a funny place. You can either, I suggest you download from open source, but if you have Microsoft, then it's pretty much easier. So if you do Python, it should be like the first one. So we're using 3.9.
Thank you.
3.10 is a beta version. If you've ever coded before in like an ECE class, you'll know like the switch statement. So that doesn't actually exist in Python, but they are adding it in 3.10. So you can see how they're constantly upgrading this as we go along. A couple more minutes. And I'd like to point you to a new extension or a newer extension called LiveShare. And if you're ever working on an engineering-based project that entails coding, LiveShare is amazing because it's pretty much Google Docs except for code. I've used this with my friends for some coding assignments, and what we do with this is I can see my friend code and he can see me code, and I can see where they are too. Like, look at this ping, it's very low. Oh, notifications. So I highly suggest LiveShare as well, if you would like to download that. It does come with Git.
Oh,
Sorry,
I'm so sorry, Christopher. I don't mean to interrupt. Do you know where this recording would perhaps be after, or where you plan on posting it?
So we will put an announcement in the CPP Hyperloop channel. I will be posting it to our official YouTube channel, and I'll post a link to that in the announcements later on.
Oh, all right. I see. Okay, sounds great. Thank you.
No problem. And Yash, just so that I can just upload the raw recording, can you stop recording this session because I already am?
Yeah, I already did.
Okay, and then you're going to start recording when your session starts.
Yeah.
Awesome.
Would it be possible to get a link to that Discord?
Yes, that is possible. I'm just going to go all the way to the end then. And then I'm going to screen share the end. So if you would like to join the Discord and you are not in CPP Hyperloop and you did not see us at Cloudflare, if you're part of IEEE, you should be able to see the Discord link there. You can take a picture of it with your phone because it's a QR code to it, or you can go ahead and copy and paste it. You guys should also have access to the PowerPoint as well, so it's on the last slide.
Oh, thank you so much. I'm so sorry for interrupting.
No problem, no problem. That's completely fine. In fact, I would like you to interrupt me if you have any questions, so I can answer them. All right. It's 2:15, so I'm assuming that everyone's on the same page-ish. So we're going to move on to GitHub. So GitHub is our way of version control. I'm going to scroll all the way back to our setup. On the right side, we have GitHub Desktop, and GitHub Desktop is a method in which we can use to organize our files in a more orderly fashion according to all the commits and all the changes that we're going to make. So when we're working in a team, we're all going to be like working on the same code base, and it's going to be hard to keep track of like where everything is and how everyone is progressing along with their script. In GitHub, we have multiple different branches in which these branches can be merged together to form, or if someone's working on something different and I'm working on something different, we can merge the code together to resolve any conflicts and then push it to the main branch. All sounds like really complicated, but I would suggest you guys make a GitHub account and then we'll create a first repo with you guys so that you can know what that's like. So everyone go to github.com and we're going to do some version control. I'm going to share my screen again. I'm going to go to these sites. So this is my GitHub page. Oops. Can everyone see my GitHub page right now?
No.
Yes.
Wait, I heard two different things. What? Sorry.
Oh, sorry. I thought you were on the website. My bad.
Oh, okay, yeah. So this is my GitHub page. You can make an account and then you can see on your profile that you have all your repositories. I've worked on a lot of projects, so I have a lot, but we'll work on creating your first repository in a little bit. So make a GitHub account, and potentially if you're in Hyperloop, we will get you situated in our Hyperloop GitHub account as well. So this is a public repository. If you are here and you would like to see what progress Hyperloop has made in terms of code, just take a look at our Hyperloop repository, and then we have all the files here. This is under the GNU license, and we'll talk about licensing maybe in a future one where we'll focus more on version control and Git. But licensing is pretty much just making sure that everyone can use this code because it's open source, but people can't use it to their own advantage. So our next topic will be on GitHub Desktop. So if you go to GitHub Desktop and download this, you'll see that this is what will pop up. You want to link your GitHub account with GitHub Desktop. Now, this is very important because that's how GitHub is going to know where to like send the code and stuff. GitHub Desktop is kind of like Google Drive, except you have a copy of Google Drive on your computer, which is called the local repository. And then you have your main branch on the cloud. So the cloud would be GitHub, and then you would have a version of that on your computer as well. And all GitHub Desktop does is it compares the version of the cloud to the one on your computer. And if there's any conflicts, that would be something you have to resolve. But for right now, we're going to just focus on getting the programs into your computer. So we're working on GitHub Desktop right now. And command line Git, I won't talk about that as much, but if you're working on a Linux machine, you will need the command line Git to access the files. So you're doing everything that's on GitHub Desktop only through the command line. So this makes it a lot easier to understand what's going on. So please raise your hand if you are at this point. So if you have GitHub downloaded and if you are ready to move on. Share for a second. Yeah, thanks, Yash. I just saw the message. I do have experience streaming, so I get really concerned whenever something pops up on my screen that I haven't intended to. Okay. Seems like the majority of you are in GitHub Desktop and have this set up. So we'll go ahead and start creating your first repository. To create your first repository, you're going to go to File and you're going to go to New Repository, and you're going to create it onto your computer. So it's going to put it inside your GitHub folder, wherever that is, and you're going to name it like CPP Hyperloop, Personal Workshop, or anything like that. You can make it a public repository. I suggest you initialize it with a README so that you know how, or people will know what this repository is about when they go to it. So an example of a README is if I go to github.com/Chris Lai. So if I go to one of my repositories, something like my Twitch bot here, and I scroll down, this is what my README is. So it contains information as to what the repository is, how to set it up, and any like licensing information that should be concerned about. So right here, I have a description of what my repository is and just like a description of how to set up personal files. So initialize the repository with the README. For the git ignore, we're going to be working with Python. And all a git ignore does is ignore certain files which are either confidential information. So like if you have a private information file with an authentication key, it'll ignore that. Or if you have a PyCache folder, if you have a PyCache with like a bunch of settings that you don't want other people to see, you'll ignore that. So I'm going to select Python. And then my license, I'm going to use GNU GPL v3. I just personally like this one because I've used it in most of my projects, but you can use like the MIT license to Apache. The bottom ones are more specific. The top three are more common. So I'm just going to use GNU. So you're going to give the repository some name. I'm going to call it CPP Hyperloop. And notice that you can't have spaces in the repository name. So you just use dashes. That's the conventional way of making a repository. You can put a description if you want, just a very short one, brief one, and then you hit create repository. Now I'm not going to do that because I already have one, but once you create it, you'll be faced with some screen like this. And you can see that your current repository will be the one you just created. you'll have a current branch with a main, and then you'll have a button to publish the repository. Now I'm just going to publish it. And when you publish something or when you do a first commit, you always want to give a description. So initialize commit of Hyperloop workshop repo. And this repository will be public. So if in case you want to use this in a resume, or if you want to show to a future employer that you did something, GitHub is a good way because it is public and the employer can see that, oh, you have experience coding. You have experience doing these things which are technical, and we want that in our team. So it's important to keep updated GitHub. If you have any projects that are not signed within an NDA, you can open source them and show that you made progress within your own realm. So I'm going to go ahead and commit this to main, and I'm going to publish the repository. And I'm going to publish it onto github.com as under CPP Hyperloop workshops. And I'm going to uncheck to keep this code private. So I want it publicized. Organization, just keep it as none for now. I'm going to publish the repository. So once I publish it, you'll be able to see that. Let me go to github.com. Here we go. / Chris Lai. And I go to repositories. I can now see it as a public workshop. Now everyone else can see this as well. So just you can see the getting right. Oh, that's not good. Okay. Yeah, that's fine. So we can see the python1.py file I created. You can also create this file as you want because we will go over some basics of Python in like approximately 2 minutes. So under the GitHub Desktop, you want to go ahead and open in Visual Studio Code. If this button does not appear, you want to go to repository and then open in Visual Studio Code down here. And if you open this, it'll open up Visual Studio Code. Hopefully, it will give you the workshop already instantiated for you. So if you go to the File Explorer on the left here, and you look at CPP Hyperloop / workshops, you can see all your files. You have your gitignore, all the stuff in it, your license, and then you can go ahead and create a new file and name it python1.py. So now we are going to move on to starting to actually code. So just a show of hands, how many of you have actually had coding experience prior to this workshop? Oh, that's good. Okay, so almost half of you do, which is amazing. The other half of you, it's really cool that you came to this workshop as well, because we are learning how to code, and this is going to be very basic ground level. So if you don't know anything about code, that is completely fine. We are here to teach you. Although this might be a little bit fast, I'd like to point you to some resources that will be able to help you outside this meeting. One I really like is, I have this on the bottom slide here. You can reference W3 School's Python, the reference, in order to get a more understanding of how to code with Python in like a work setting. And this has it's a very intensive, very descriptive definitions. I use it to like review myself sometimes because I can't remember everything about Python. So I highly suggest going to this website, and when you do your projects, you can reference it, and it'll be really a great help for you. But now I'm going to go to the basics part 1, and we're going to begin talking about Python skills. So the basics. We have print statements, inputs, outputs. So what are those, right? Usually at a very ground level for Python, we're going to print something out onto the terminal, and we're usually doing this to troubleshoot some issue. So print statements are cool and all for like, oops, I moved on. Print statements are cool enough for like projects and things, or like, I know like probably if you take in a coding class ever, they tell you, oh, print hello world. And that's pretty easy, right? You can just go ahead into your Python and type in, I don't think I'm sharing the right thing here, but print statements are really easy. You just go print, of course I spelled it wrong, print hello world, right? This is like the most basic line of code. In Python, there are no semicolons. So indentation is very important. But you put hello world inside of quotation marks to indicate that it is a string. So if you press play, you can see that down here, it'll say hello world inside of the terminal window, which is very nice, right? So this compiler is a top-down compiler. It'll run code from the top of your code to the bottom of your code. So the order is very important. So you can go ahead and try to type in hello world into your compiler just to make sure it works. Usually we use this as a form of troubleshooting or debugging. If we don't know where the code is messing up, we're just going ahead and say print maybe like test maybe like test 1 at some line of code just to make sure that it reaches that point. If it reaches that point, that means that it's not where the bug is. We have to like go back and like check it a few more times. This becomes really apparent when your line of code becomes like thousands of lines long. You're trying to like find where you messed up. So along with this and other troubleshooting techniques we'll go over, it's a very good way to like optimize your coding experience. So from print statements, we also have input statements. So if you want to make a
Chris?
game, yes.
I do not have the start button that I can press like you do have.
Okay.
Yeah.
Did you download the Python extension?
Yeah, I did. So I had Visual Studio Code open. I downloaded everything and I was kind of playing with it before. But then once I opened the where is it, the GitHub, when you said, oh, open the repository in Visual Studio Code, now it opened.
Okay.
There,
does your file name have the extension .py?
Oh, it does
That's
not.
incredibly important.
Okay.
So when you, sorry, I should have covered this before, but the extension, if you look on the top left corner here, defines what kind of file it is. For example, if I do .cpp, suddenly it's a CPP file, right? So that's a very important thing I forgot to mention. Sorry about that. But let's keep .py for now. Visual Studio Code is very smart. So if you just name it nothing, it considers it as a text file. So you can also edit text inside here as well. Okay, so moving on, we have print statements, but we're going to talk about variables in a sec. So variables are little storage elements inside the code in which we can use to store different things like integers, doubles, floats, strings, characters, booleans, lists, dictionaries, objects. The list goes on, right? But it's just a little storage element which we can reference later from another point in time. And I hope you guys are following along with the PowerPoint because I'm sharing my screen here. So this would be slide 4. Or slide 4 or 5. It's the basics part 1. So we're going to create a variable called user input. And user input, we're going to take in the user's input, obviously. Your variable names need to reflect on what's being like put in. So usually I have user input, but it would be really confusing if you put like just X, right? What's X? Usually single letter variable names are used for iterations. So iterations such as looping through a for loop, looping through a while loop, counting a number, etc. Those are called iterations. So I'm just changing this back to user input. Now, look what happens when we run this code. The code goes from line 1. So line 1, it's going to say user input is equal to this function call. Now, we know that the input, if we hover over it, it'll show us that the input function reads a string from the standard input and the trailing new line is stripped. So whatever you type inside the terminal window, that's going to be the user input. Now, it returns it. Look very closely at the red arrow pointing to string. So that's what the function's output is. When you call a function, its return type is a string. Therefore, our user input variable is going to be a string. Now, the very confusing part about Python is that you, unlike C or C++, if you've ever coded before, you don't define the variable type. You have to implicitly know it, which means that it's very like, unlike C, it just yells at you if you like code something incorrectly. But here, we have to know that our input is a string. So that our user input, we can go ahead and do print user input like that directly. On line 2, we reference the user input variable from line 1. So we put the input, whatever the user types in, we're going to print that into the screen. And I'm going to go over some real quick skill called concatenation. So we can add strings together. So I'm going to say, you said this, right? And the plus sign here is a form of concatenation, which is concatenation is a fancy word for adding strings. There are multiple ways to concatenate strings. This is just the easiest one. There also is a way which I like to use called using an Fstring. So I'm going to do F you said, and then I'm going to do curly brackets. Now, anything in the curly brackets is considered a variable. So I'm going to put user input as here as well. So these are two ways to concatenate strings together. And I'm going to leave a comment here describing what I did. So comments are very important as well. So I'm going to leave a comment saying get input from user, print it out. Concatenation. If I press play, nothing's going to happen yet in the terminal window because it's waiting for me to type in something. So I'm going to say hello, hello there. When I press enter, the terminal window is going to say you said hello there, referencing line 3. And it's going to repeat the same thing because I concatenated using an Fstring. So Fstrings are really useful when it comes to figuring out what variables to put in a string. Like say you want to print out something as a troubleshooting message, and you want to find out what the variable is at a certain time. So you go say, okay, variable X is equal to, and then use an Fstring and you put the variable inside. That's just a very useful way to use an Fstring for now. We're also going to go over multi-line comments, which I'm going to use for the purpose of putting everything in the same file. So multi-line comment is how you comment out multiple lines, kind of like this. It's 3 apostrophes, and then Visual Studio Code auto-completes it for you. Okay. So we've gone over the basics of part 1. We can go over multiple data types if you're completely new to coding as well. So are there any questions as of so far? I don't want to lose anyone.
So when something is red, it means that you messed up something. Because like my parentheses, the squiggly one, you have, I think I saw that yours were blue and mine were red. And then when I inputted, nothing really. I mean, I got hello world, but that was it. So does that mean that you do something wrong if something is red?
All right, so I'm going to cover both of these. I see Aaron has a question. When I try to run and debug, I just get indentation error, expected indent in the terminal. So in Python, since there are no semicolons, indentation is extremely important. You have to have everything from like the first indent. Make sure your comment isn't, there's no extra space here because that'll break it. In addition, you have a linter. A linter is a compiler for Python. That's what the extension you downloaded does. So if you get like a red squiggly line, for example, if I just add an extra parentheses here, you'll see that it yells at me in like 4 different ways, right? It's saying that if I hover over this, it says statement must be separated by new lines or semicolons. It's because it thinks it's a new line. But if I just delete it, it goes away. So you need to make sure you have it copied exactly like this. If you're new to coding, you may be confused as to what the function statements are. But when we print something, we need to open parentheses, close parentheses at the end, and then whatever inside the parentheses is what we're going to be calling. So we're going to print stuff inside the parentheses in my case. Aaron, did you get it to work, or did I answer your question, Eduardo?
Yes.
Okay.
The only thing is that I do not get you said hello there or hello world. It's I don't know what it is, but I can always my F is not blue, it's white. Everything else kind of matches your color.
Okay. And your F is before the parentheses, right? Or be it before the quotation marks?
Yes.
So
wait a second. Maybe no. Oh.
So I'm gonna put it in the chat so you can copy and paste and see if it.
Oh yeah. Okay.
Make sure you have user input variable defined, and then that's it. And if you just want to do hello world, I'm gonna multi-line this out. So the basic hello world.
Yeah, it's the same. I copied yours, but the half stays white. So I don't know.
Okay. If you run the code, does it have any issue with it?
Let's see. It just I just got a hello world and that's it. I do not get anything.
So if you don't have a variable name being called on there, see. Oh, this still has an F string. That's weird. I might have to check it out to like see what's going on. So
yeah, it's fine. I'll try to work on it more.
Could you give an example of where the F function is used over the normal one? Of course. So the input statement is pretty much that, basically. So I'm going to comment this out. So let's say we have a bunch of different variables, right? Let's give a condition, or let's give a scenario that I am buying. This is what I want printed out, right? I am buying 32 oranges, 5 apples, and 4 bananas at the store. Now, if you want to concatenate this, right? Let's say oranges as a variable is 32, apples is 5, and bananas is 4. If I were to try to print this out, so I am buying, and I want to put in oranges, the number of oranges. Let me just rename this. So number of oranges, number of apples, and the number of bananas. If I want to concatenate this, look how difficult it will be. So I need to do num oranges plus, and I have to make sure that there's a space here because there's no space inside this number. Yeah, maybe a different color scheme. If it works though, that's why I was asking you if it runs, Eduardo, because if it doesn't run, then it might be a problem with your Python code, and that I'll have to like look at later. So oranges, I'm just gonna like not do the rest of this because it's kind of the same thing. Oh yeah, and it can only concatenate a string, not an int string. So we can use the string function str just in case we have a number. This will turn it into a string, and then it'll add it to my function call here. So it says I'm buying 32 oranges. For every time I need to concatenate something using the plus sign, it's going to get longer and longer and longer, and I'm going to hate myself eventually for it. So instead of that, I'm just going to use an f string. So through an f string, I'm going to say I am buying number of oranges, and then I'm going to open close parentheses again, num apples. And you can see when I'm typing this out, the Intellisense is actually giving me suggestions as to what to complete my statement with. And the GitHub AI has gotten so advanced that it can even write entire lines of code for you. And that is an extension. I think it's like a GitHub helper or something like that. But Intellisense is also very smart because it knows what variables you've made and how to call it. Bananas at the store. So using this, I have to put in multiple different variables. I think I'll have to like, it's going to yell at me. Oh, no, it doesn't. So if I put a number inside the f string, I actually don't have to turn it into a string because Python is smart enough to turn itself into a string before printing it out. So f strings are used for optimal coding, pretty much. I know f strings probably don't exist in some other languages, but in Python, if you have like a lot of code that you have to like read and troubleshoot, this is the best way to find it. Like if I have a lot of code before this and I don't know what the value of number of oranges is, I can just call it in a print statement and run the code and see what happens. So that's just a quick intro as to how that goes. And I already know that I'm probably not going to get to all of the Python because it's a bit ambitious to stuff everything into like one meeting. So we're probably going to have multiple Python workshops scattered throughout the semester. And we're still like planning that. But as of right now, Python 1 is just going to be today. So this is an example of using f string. F string to optimize if statement. Okay, so the next thing we're going to, by the way, when I instantiate the number of oranges, number of apples, and number of bananas, these are integers. Integers are whole numbers, all right? So integers, we're going to go over some data types here. So integers are whole numbers, and they can be negative. So I can have sample int equals 5, and that's a valid integer. I can have sample int equals -1, and that would be a valid integer. And the next data type would be a double or a float. I know in C# and C++ floats exist, but and you're concerned about the memory that it takes, but in Python, we just throw that out the window. We don't care much about memory until we get a segmentation fault and we are unhappy about it. But we're just going to be using doubles for now. We're not going to be concerned about floats. Doubles are decimal numbers. They can also be negative. So I have sample double equals 6.25 or 6.55, and you can add as many decimal places as you want, and it'll still be fine. We have strings. Strings, so sample string. You have to encase them in quotation marks so that like you can write text in them. So this is a string. You can have booleans, and I really like booleans for state machines. In Python and robotics, you can have different state machines in which state machines are different. Redundancy aside, there are different states in which something happens in one state, something happens in another state, something happens in a third state, something happens in a fourth state. For example, in a robot standpoint, we can have state 1 being the robot raising its hand, state 2 being the robot like putting its arm out to the side, state 3 being the arm like downwards. And we can call these states to tell the robot which position to be in. That's from a hardware standpoint. From a software standpoint, a simple state could be a button. If you're making a graphical user interface, you create a button and you can press that button and it can turn a variable to true. So booleans would be like a sample bool equals false. And booleans can only be two things. So false and can be true. The next data type is called a list. A sample list. Now, in some other languages, you might have heard of this as an array. And some languages such as C, I think C, arrays cannot be, or C and C++ essentially, arrays are not mutable, or arrays are immutable. If you heard that word before, it just means that once an array is declared, you can't change the size of it because it becomes a memory issue. That's where lists come in. So in Python, arrays do exist, but you have to like import them in. They're part of like NumPy, which is an external dependency. So a sample list kind of looks like this. You encase it in square brackets, and whatever elements you want to put in, you just like start putting them in like column form. So I'll just print this out just to show you that this works. But you can think of lists as kind of like a cabinet with like many little storage elements in it. So that's the analogy I like to use. But if I print out sample list here, you can see in the terminal window, it says 0, 1, 2, 3, 4, 5. Now I can call multiple elements, or I can call a single element from a list by using a, let's put this as like 3, 4, 1, 6, 5, like here's some random numbers, just like differentiate it. I can call different elements from a list using an iterator. Now, iterator of an array or list, the first element is actually item 0. So the first one is item 0. I know it's kind of like counterintuitive to think about, but if I call sample list 0, look what happens. It's going to give me 34. And if I call sample list 1, it's going to give me the second element in the list, which is 165. So through this, I can call multiple different elements of a list just by putting in the chat like that. So look what happens if I do sample list at -1. Now, -1 doesn't even exist in the list, so I'm assuming it's going to give me an error. But it doesn't. And why is that? Because usually if you do this in some other programming language, it's going to yell at you. But if you put in the negative number, which is really cool, it actually starts going backwards in the list. So -1 would be 45, -2 would be 54, and etc. But look what happens if I put something way out of range, 10. It finally gives me the index error. So you can go negative in a list, but if you want an error and it gives you an out of range error, you have to try to find one where it's like not even in the length of the list. By the way, you can find the length of a list by just doing print. I'm going to do length of sample list. And here's another iteration where I use an Fstring. So the length of sample list is going to be sample or length of sample list. So the length function is a built-in Python function where it finds the length of just a singular list. And here we can expect it to output 1, 2, 3, 4, 5, 6 different elements. So it should output 6. If we hover over it, it says that the length function returns an integer. And the description just says return the number of items in the container. And our container being our list. So okay. I can't call the print statement, right? Because it's still giving me the list index out of range. So sometimes in coding, you're gonna have to find a way to bypass this. You're gonna have so many errors, you're gonna have to find a way to bypass it. And since we're running out of time, I'm going to, lists are probably gonna be the last thing I'm gonna talk about. And I'm gonna talk about some applications we use of Python and Hyperloop, and then we'll continue sometime next week, probably. I'll talk with my team leads, and I'll talk with IEEE leads to coordinate that so we can get more workshops together. So I'm going to move on to our troubleshooting slide. So I believe this is slide 6 here, if you want to reference it on the slide point. When we're troubleshooting things, sometimes when we're writing in code, we're going to run into a lot of errors. In this case, we have list index out of range errors. So I want to print my length of the sample list. I can either, to solve this issue, I can either comment this out, or if I don't want to comment it out and I want to see, I want to bypass it in a sense, I can use a try catch block. In other languages, it is called try catch, but in Python, it's called try except. So all this is going to do, and you can use this even in the most basic forms of coding, except pass. So I want to keep this code block. Usually, in this case, it's only one line, so I can probably comment it out. But if it's like 10, like a huge code block that I can't relatively comment out, and I still want it to be inside it, I can do try print sample list 10. And since that I know that's going to throw me an error, it's going to pass it. And then it's going to print length of sample list, and then it's going to this should work. So it prints length of sample list 6, bypassing the error. And what if I want to see what this error is? So sometimes we want to see what the exception is in the code base without having to actually run into that ourselves. So if we try something and we're not sure if it's going to throw us an error or not, we put in a try catch block, and then we say accept exception as E. And here we're going to print E. So this is going to tell us what the error is, but it's not going to completely stop our code, which is what our troubleshooting is for. So try, except, finally, those catch blocks help us with deciphering what's going on in our code. So it says here that our exception is list index out of range. Now, if I have a lot of stuff printed out on the terminal and I'm not sure what this is, I can go ahead and use an Fstring. So Fstring, I'm going to say, what's wrong? And then I'm going to do my curly brackets. I'm going to close the string. Okay, so I'm printing what's wrong, and I'm printing the error. So I'm going to press play, and then it says, what's wrong? Oh, the list index is out of range. So my length of sample list is still 6 in that case. All right. Any questions from anyone at this point of time? See the chat. If you are getting an expression error, like a pylance error, a pylance error would be, it would be like something's wrong for a compiler. If it's pylance, that means that the code itself isn't actually running. What specifically error are you getting based on that? What's your error statements? Okay. If your code base isn't working at all, and that's becoming too much of an issue, feel free to just private message me in Discord. send me an image of your issue and I'll go ahead and try to fix it, because it's better if I like know what's going on. All right. No problem. But just a show of hands, who has gotten all of this working on their screen so far, just so I can see if I can move on. How many people have I lost? Oh, okay, awesome. We actually have a few members who are with me. Awesome. Thank you guys. Really appreciate it. So at this point of time, I'm going to start wrapping up my work for the workshop, or it's almost time to move on to the CAD one. So what I'm going to do now is I'm going to be a good little coder and commit my changes. So you all should have created this inside a GitHub repository, and I'm going to go ahead and update it. Now, a really nice trick, a new visual trick I like to do is I like to put an emoji inside the commit message as to show what I changed. So when you're working in a code base or a code team, when you're finished working on code, you're going to have to commit it. And when you're committing it, you have to put a commit message. And this commit message can be anything as long as it pertains to your whatever you did so far. And I know some workplaces get a little bit irritated based on the people not leaving good commit messages. So I really want to make sure you guys make a good commit message. And one way is by making it look nice. So I'm going to go ahead and do a check mark emoji. And you can honestly put any emoji you want, as long as it's relevant to what you're doing. So I'm going to put a check mark here. I'm going to say basics of coding up to lists and troubleshooting using try accept. Okay, so that's a commit message. If someone goes ahead and reviews my commit, if you're going to software in the future, your colleagues or like the senior code interviewers are going to go, hey, I want to review your code message, to make sure when they put it into like the real code base and have it working in real time, then you make sure that you didn't mess up somewhere. So the commit message is just like an initial really good way to make sure that everyone around you knows what you did. And also, I'd like to stress the importance of leaving comments as well. You can see here on my screen that I left comments for everything I'm doing. Usually that's excessive commenting is not good, but you need to leave comments for like function calls, different like logic, different algorithms you're going to write, just so that you want to make sure that whoever's going to look at your code understands exactly what's going on. Because everyone codes in a different way. I code in a different way. You might find out you code in a different way in the future, and that's completely fine. But comments in English are like what everyone understands, and that's why it's so important. Okay, I'm going to go ahead and commit to main. And it says committed just now. I'm going to go ahead and push to origin. And when I push to origin, it's going to take the code from my local computer, and it's going to put it all the way up into the cloud. And the cloud is our GitHub, github.com. So I'm going to go back and look at my github.com/Chris Lai. If I go to my repositories and my workshops, I can see that, oh, look, a new commit message has been done. I have committed basics of coding up to listen troubleshoot using try accept. And since I had absolutely nothing inside the code base before this, I can see all my changes on the right here. And you can see that the GitHub automatically detects it as a Python and corrects it accordingly. So we went all the way up to try catch blocks and printing of a sample list. And I think that's a pretty good stopping point for today. For right now, I'm going to direct your attention back to the PowerPoint, and we're going to go over some quick applications of Python and Hyperloop and how we're using it in the team. Okay, so can everyone see the PowerPoint as of right now? Okay, awesome. So different game ideas. If you were here during the last year's IEEE workshop, I was actually leading that. And we made a blackjack game, which is really nice. But different game ideas are actually really good practice for coding, because people like games. People like the idea of risk and return, right? So different games you can make with Python, which are possible because I've made them before. And if you would like to actually make a game with this and actually design it yourself and put it in your GitHub repository, and you can let CPP Hyperloop know, and we'll actually put your submission up onto our social media. So like our Instagram page or LinkedIn page. and we can showcase it off in our Discord channel. So it's just a way of giving back. So if you want to showcase your work and just show off what you made, we can help you show that to the world in some sense. If you need help making any of these games on yourself, if you want to do any of these prompts, you can feel free to ask me, feel free to ask the Discord channel, and feel free to ask like the people at IEEE. I'm sure there are many people over there who also do know how to program in Python and are willing to help you. So some game ideas: blackjack, trivia game, hangman, word shuffle, and the last one's a fun one, random number battle, which I had actually demonstration for everyone today. So it's actually in my Discord, so I can go back to it. One project I've worked in over the years is a Discord bot in which it was for my stream on Twitch. So I actually started streaming on Twitch, and it was a fun opportunity to document my work over the long run. And everyone can see my Discord channel as of right now, correct?
Yes.
Okay, thank you. So if I do roll, this is just an example of how you can use Python to create a game for myself. So in a random number battle, the goal is to roll a number higher than your opponent, right? It's a very simple game, although I've kind of like spiced it up a little bit. So I do !roll. My bot goes ahead and says the computer rolled 75 while you computer rolled 74 while I rolled 75. Again, these are randomly generated numbers. Wow, it seems I rolled one higher than the computer. So it says that I've won and I've earned like some amount of points. So this Twitch project is also available on my GitHub repository and also available on my Twitch if you want to see some of my videos coding it throughout the last month. But that's just an example of what you can do with Python. So this bot is completely coded in Python. Oh, and Hyperloop applications, I'm going to go through a few of them. They may sound a little bit advanced as of right now, but they are incredibly relevant to the team. So the main deal with Python for the team is that we want to transfer data from place to place. If a Hyperloop pod is going along the track at X speed, and it contains different sensors such as the speed sensor, the temperature sensor, the battery sensor, we want that data to be able to go through a server and onto our computer so that we can see that the Hyperloop pod is doing fine. So on our computer, we have a graphical user interface, which is also coded with Python as of right now. And this graphical user interface shows the data that's being sent from our onboard sensors. So inside our actual design, we are using our microcontrollers such as Arduino and Raspberry Pi. They're not microcontrollers, don't call them that. But our controllers will take in the sensor data, feed it into the Raspberry Pi, and the Raspberry Pi has a Python client inside of it. And in the future, I hope we'll get to talking about socket and tkinter because those are really fun code bases and dependencies to work with. Socket is our server protocol. So we open a socket and allow the Raspberry Pi to connect to a server, a virtual server, through our, we'll allow the Python client to connect to a server through a socket protocol, and it'll transfer data to the server. Then it'll take data from the server and transfer the data over to our computer. So this kind of connection is called socket protocol. Bidirectional communication is important in our team. And we have here our goals for that. So we also have serial data and controls as part of our code base. We want to know how we can control things using the serial through Raspberry Pi. And we'll go over that in the later workshops. And also how we can communicate with hardware. So in that case, one of our hardware team's goals is to be able to communicate with the Arduino and Raspberry Pi as sign of a serial connection. So how do we use our Raspberry Pi, which is in Python, to communicate with other devices as well? Now, I know this is a very robotics-based application, but there are also many different software-based applications I didn't go over, just that we don't use it much in Hyperloop. So this is very project-oriented based as to what we're doing. So if anyone is here, anyone here is coming here for an intro to Python for Hyperloop, that's what we're going to be using it for. And so that will conclude my presentation for today, exactly 1 hour, which is very nice. Unfortunately, I did not leave any time for questions, so I'm going over to Yasha's time here, so I apologize for that. But if anyone has any last-minute questions, please feel free to ask them now.
Real quick, you said that there was like a website or somewhere where there is a lot of information about Python. Where
Yes.
is it? Because I can't find it in the slide.
So it is in the notes. I'm also going to put it in the chat.
Okay, thank you.
All right. So if no one has any other questions, I'm going to hand it off to Yash. If you do and you didn't get the chance to ask it, feel free to use the help desk in the Discord channel. If you're in IEEE and you haven't joined the Discord, there's a link right there. Go ahead. You don't need to become a member to attend these workshops. If you want to become a member and receive the opportunities and like the resources that we provide, you can feel free to do so. Just sign up on my bar, change your Discord name to your real name, and then we'll get you hooked up. Sound good, everyone?
Thank you.
All right, thank you, everyone. So the next workshop is the CAD workshop led by Yash, and the floor is his. All right, I'm leaving, everyone. So see ya.
All right, see you, Chris.